This lesson uses an LTspice simulation to examine a transistor shunt voltage regulator. We shall first establish the direct current operating point and compare it with the hand calculation. We shall then vary the input voltage to study line regulation and vary the load to study load regulation. The central idea is that the transistor absorbs or shunts the current not required by the load. Regulation is therefore possible only while the source provides enough current and the transistor still has spare current to shunt. At the design point, the Zener voltage and the base emitter voltage set the regulated output close to 8.9 volts. The series resistor current is the input to output voltage difference divided by 120 ohms, giving about 109 milliamperes. The load draws about 89 milliamperes, so approximately 20 milliamperes remains for the transistor branch. LTspice gives an output of 8.908 volts, in very close agreement with the ideal hand value of 8.9 volts. Notice one modeling detail. The simplified hand method calls the leftover current collector current. In the simulation, it is actually emitter current because it also includes about 0.39 milliampere of base current. The approximation is acceptable here because the base current is small. For the line regulation test, the load resistance remains at 100 ohms, while the input voltage is swept from 15 to 30 volts. Below approximately 19.5 volts, the Zener diode and the transistor are essentially off. The output then follows the ordinary divider formed by the series resistor and the load, so there is no regulation. Once the input provides enough headroom for the Zener and base emitter junction, the transistor begins to shunt excess current and the curve flattens. Between 20 and 30 volts, the output changes by only 0.15 volt or about 1.68%. The graph therefore shows both the unregulated region and the regulated region clearly. For the load regulation test, the input remains at 22 volts while the load resistance is stepped from 50 ohms to 2 kilo ohms. With the 50 ohm load, the load attempts to draw about 129 milliamperes. The series resistor cannot supply that current while maintaining an 8.9 volt output. So the transistor turns off and the output falls to 6.47 volts. When the load resistance reaches 100 ohms or more, spare current becomes available for the transistor to shunt and regulation resumes. Across 100 ohms to 2 kilo ohms, the output changes by only 85 millivolts, about 0.96%. The practical conclusion is important. A shunt regulator is simple and tolerant of a short circuit, but it has a maximum useful load current and continues to dissipate power even at light load.